I'm going to give you, again, a couple of minutes, or a minute maybe, not too long, to have a go at this. Whilst I charge my pen, whilst I talk through how to approach it. So have a go. It's only 2 marks, so hopefully it wouldn't take you more than 2 minutes, but we don't have 2 minutes, I'm afraid, so we're going to do a bit shorter. Have a go, see what you think, and see if you agree. So carbon monoxide and hydrogen gas react to form methanol in a sealed container under standard conditions. Blah, 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 blah. State and explain how the concentration of methanol at equilibrium will be affected if the pressure in the reaction vessel is doubled. So, context. Here, again, equilibrium. So I'm thinking about my equilibrium section of my revision. Specifically, concentration of something when I'm doubling pressure. That's the specific area of my revision. That's where my direction has been given. And the command word is state and explain. So it's 2 marks, 1 for the state, how it's going to change, how it's going to be affected, and 1 for the explanation of how it's going to be affected. 2 marks. So context, the equilibrium, and the effects of changing pressure. The command word is a statement, and then the explanation. So a simple answer followed by reasoning. And my direction is how is it going to change when we double the pressure. So I would write something like this. So I would say concentration of methanol increases as the equilibrium, because product is favored is at high pressure, as there are 3 moles of gaseous reactants on the left-hand side, forming 1 mole of gaseous product on the right-hand side. This is in order to lower the pressure. So we could say something along the lines of concentration of ethanol increases as the equilibrium shifts towards the products, which has fewer moles to lower the pressure again. Hopefully that's something that you said or something you were going to say. What about this example question then? This exemplar question, this is a calculation. Again, please feel free to rush ahead and have a go while we're talking through it to begin with. If you want to go through it with us, that's absolutely fine. So propanone reacts with hydrogen cyanide in aqueous solution to produce 2-hydroxy-2-methyl propane nitrile as the only product. They've given us the formula of that. So if you're not sure what it is, you have been given the structural formula as the only product. This reaction is reversible. We've been told it's reversible. We've also been told the initial moles must be more than 1. In a closed system, if the total volume of solution is 5 decimeters cubed and hydrogen cyanide is in excess, calculate how many grams of propanone are needed to produce 1 mole of the product at equilibrium. Under standard conditions, Kc is equal to 25 moles to the -1 dm cubed. There's a lot of information in there. So just take a second to work out what on earth what information they've given us. What's the context? What's the command word? What are they looking for? What direction have they given us? Context-wise, I can see we're talking about equilibrium and specifically Kc. Command word, calculate how many grams of propanone are needed. So we're looking for a calculation at some point in the marks. It's 6 marks worth, so there's a lot. I can see there's going to be a lot to go on there to get to that calculation, or to complete that calculation. And directions, well, I've been given lots of information. So let's think through it. Oops, sorry. Context, command, and direction. So this is the equation we've been given. If we've got Kc involved, hopefully a little flag has gone up to say, well, Kc's involved, I might as well write an equation. Let's have a go. Write out an expression for Kc. Well, we've been given the balanced equation, so hopefully we can just write that straight in. So concentration of our product. So CH3C CnOH CH3 aqueous over the top of the concentration of our reactants, so CH3COCH3 and HCN. All of them have a stoichiometric value of 1, so they're all raised to the power of 1, so I'm not going to write it in. Can I work out the concentrations? I've been given very little information, so this is, this is feeling hard, but what information have we been given? Well, we know how to calculate concentrations. I need concentrations to input into my Kc expression. So let's have a go at trying to work out what information we've got and what we can work out. So concentration is given in moles per decimeter cubed. And it's equal to the number of moles in mole. Oh, bad handwriting. Times the volume in decimeters cubed. Has to be in decimeters cubed. Whoops. There you go, decimeters cubed. In the question, was told that the total volume of the solution is 5 decimeters cubed, and we're trying to produce 1 mole of the product at equilibrium. So my concentration of my product is therefore going to be 1 mole of the product at equilibrium in a volume that's 5 decimeters cubed. So 0.2 moles per decimeter cubed. That's the concentration of my product. Now, how do I work out the rest? Well, hydrogen cyanide is in excess. That was given to us in the question, meaning the limiting reagent must be propanone. So that's what's going to determine my amounts that have moved. Now, you might be used to doing an ICE table or rice table. Some people call it rice for ratio at the top. So how can we do it when we've got very few numbers? Well, let's have a look at what information we have got. I'm going to use X as the number of moles of propanone required. So I know I've been asked to determine the grams of, so mass of propanone required. In order to get to mass, I'm going to need moles. So I'm going to use X to denote the number of moles of propanone required. So that's what I'm trying to find. I know that HCN is in excess. So it's not the limiting reagent, but in order to determine how much has reacted, I can use X because that will have reacted with my propanone. And I will have started with no moles of propanone because it's a product. So I started with none of it. So my amount at equilibrium, I wanted to produce, what was it? 1 mole of the product at equilibrium. So I'm adding 1 mole of propanone. If I'm adding 1 mole of propanone, I must have had 1 mole of each of my reactants react to get that 1 mole. So my amount at equilibrium, my number of moles, will be X minus 1 moles of each of those, which means my concentration at equilibrium will be X minus 1 over 5, because my volume is still over 5, is still 5, sorry, and X minus 1 over 5. And then I've already calculated my concentration as 0.2 moles per decimeter cubed. Sorry, I should have written my units in. Oh, no, I shouldn't because I've got it in the thing. That's fine. Sorry, moles per decimeter cubed is already in the table, so I don't need to add it in. Okay, so my number of moles of propanone I already calculated, and I've still got some unknowns. But I can work it out how to use that, or I can use that, sorry, because if I add in my, so this is product over reactants, we've already done it before, so just to save time, I'm just going to write products over reactants is equal to 25 moles per decimeter cubed. That was given to, sorry, moles to minus 1 decimeters cubed. That was given to us in the question. Kc is equal to 25. We've given that in the question, which if I plug in my numbers of my products over reactants, I've got 0.2 over X minus 1 over 5 times X minus 1 over 5. Now, still looking really complicated, but keep following it through. If I times everything by, and I might run out of space to do this, but hopefully I'm going to be okay. If I times everything by X minus 1 over 5 times X minus 1 over 5, just to get that off the bottom of the equation, because having fractions is a bit horrible, so I'd rather not. So let's times everything by the bottom of the fraction. I end up with 0.2, because that's now not part of a fraction, which is nice, times by, sorry, is equal to 25 times by X minus 1 over 5 times X minus 1 over 5. Can I simplify anything? Well, if the bottom of this fraction, if I simplify this section here, I've got divided by 5, and times by 25. Well, they cancel then, don't they? they would cancel. So if I combine these equations, my 25 times by 25 divided by 25 would cancel. And I'd end up with 0.2 is equal to x minus 1 squared. Now, how do I deal? How does one deal with quadratic answers? If you think back, way back to your GCSE knowledge, what we should be able to determine is that because you've got x minus 1 squared, you can have plus or minus the square root of, so it's got to be plus or minus the square root of 0.2. So I've gotten rid of the squared is equal to x minus 1. And then I can rearrange to work out what x is. So plus or minus 0.2. So if I do plus or positive square root of 0.2 equals x minus 1, rearrange to find x, I'll get one answer. And I do minus the square root of 0.2 is equal to x minus 1, and rearrange to find x, I will get another answer. And it should be these 2 moles. Notice there might be, oh no, that's fine. Yeah, so one of these two. Again, if we go back to the question, it said the initial moles have to be more than 1. So I can discount that answer, and I know my answer must be x is equal to 1.45 to 3 significant figures. Not an easy question, that one. And we haven't finished yet because I've got the number of moles of propanone needed. But the question asked us for the mass. They asked us for grams. So what equation are we going to need to use to work out grams if we've got, or mass if we've got moles? It's hopefully n equals m over mr. So that's the number of moles. Number of moles in mole is equal to mass in grams over the molar mass in grams per mole. Or I could give that in grams moles to the minus 1. So let's work out the MR. I'm trying to work out the moles. No, sorry, I'm trying to work out the mass of propanone. So I need the molar mass. So the molar mass of propanone is going to be 2 lots of 12. No, sorry, 3 lots of 12 plus 1, 2, 3, 4, 5, 6. 6 lots of hydrogen, of 1 for hydrogen plus 1 lot of oxygen to give me 58 grams per mole. I can rearrange the equation. Mass equals moles times mr, which in this case is 1.45 to 3 significant figures, times by the mr of 58.0 gives me 84.1 to 3 significant figures. So that's the final answer. So it's a long question, that one, and hard. Lots of people would have struggled to get there. But what you can do, like we said before, I'll say really briefly because then I need to move on. What you can do is if you can't work out the number of moles of propanone, make up a number. Make up a number, say x is equal to 1.2, and then work out the rest, because you can at least get the marks for the end of the working. So if you come across this question, you think, I have no idea how I meant to work out those number of moles, but I know I'm getting to a mass at the end of it. So I know I'm going to have to go from moles to mass. We'll just do that bit. Make up a number. You won't get a mark for the number of moles, but you'll get a mark for determining mass from moles. So always worth making up answers if you can't come up with an answer.